Hello and welcome to the fourth Unity Camp tutorial video. This one will hopefully not be as long as last video, but in this video we're basically going to be tuning the player's jump and making it feel a little bit better, and then adding a basic enemy that will be able to interact with the player can kill the enemy, or the enemy can kill the player. So if you remember from last lesson, if we hit play, we can walk around, she'll move and change direction, and you can also jump. But the jump is fairly slow. It just kind of slowly goes out and then slowly comes back. And there are ways to fix that. Now, if you remember, under player, we have the ability to change the jump force. So if we were to change that to like just a little bit higher, maybe a 9, hit play, and it's a bit faster, but also way higher. So there should be a way to fix that, and in fact there is. And to do that, we're actually going to need to edit the project settings, which isn't something you typically a lot of the project setting edits, like I've said before, can just be done in code, and then so it won't interfere with the whole game. But this is something that you really need to edit for. So if you go to Physics 2D, you're going to see all these options here, but the important one is gravity. So gravity at the moment as a x of 0, because we don't want her to be at the moment, unless you might want a player to constantly be moving to the left slowly, but I don't think that's what we really want in our game. And then the y gravity is negative 9.81. So that's actually mirrors what happens in real life. There's the gravity is negative 9.81 meters per second squared. And in real life, that's pretty nice. But in a game, that's not always what we want. Maybe we want her to jump a bit faster and then fall a bit faster. And to do that, we make gravity stronger. So maybe instead of 9.81, we'll say negative 15 for gravity. Now, you can see it's a bit faster, but it's also smaller. If we try setting gravity to say negative, let's say 60, yeah, barely any jump, and just comes right in and comes right out. So I'm gonna just adjust it to a midpoint, sort of. We'll say negative 25. Alright, it's fast. I would like her to go higher. And we can change that like we were doing before with the jump force. So if we change that to a 10, now she's moving very quickly, but also moving very high in her jumps. So we're running it right now, so let's turn that off. Go back to project settings. I think I'll put this at a negative 25, and I'll put the jump force at around an 8, and we'll see how this feels. Alright, it's still a bit slower than I would like. Maybe put it at a 9. Yeah, I do like how that feels. So I think that's a good balance. So what I'm doing is a jump force of 9 with a gravity of negative 25. And you can feel free to customize that. By all means, make this game your own. Do what feels right for you and what you want. And basically what we're doing, if you're a bit confused, is the gravity is how fast the downward pull is going to be, and the jump force on the player is how fast you're moving upwards. So you kind of need to find a balance that works right, of having a jump force to move upwards a certain amount and at a certain speed, and having a gravity that's pulling you down at a specific speed. So I'd say I like the feel of a 9 jump force and a negative 25 gravity. So I'm going to save that up. And now that we have the player's jump feeling a bit better, we can start with the main focus, which is the enemies. So to get started, I'm just going to make a bit more space, because right now we just have this teeny tiny platform. I'm going to take this collider and just adjust the Y and make it way wider. It's still as ugly as always, but that's not really important right now. So I'll adjust the scale. I said collider before, my bad. And when you adjust the scale, the collider should adjust with it, which is really nice. So that's good. And then I'm going to just create a couple walls so things aren't just constantly falling off. So if we go back to our prefabs, we have the player and then this game object. We'll drag one in, and we will adjust first we can adjust the position. You can just hit W, and then you can move this around, and then we'll make it a bit thinner, bit wider upwards, and we'll just kind of put this there as like a wall. Then we can make a new one. You can hit Command D to duplicate, or Control D on a Mac, and we'll just take the position and just, whoa, that's a bit too far. We can just bring this over here. Now, one thing I don't think it really matters because we're not going to be using these platforms in the finished game. But one thing you'll notice is that when you hit overrides, you can apply all. So, for example, maybe we want to keep it so this is what it's going to look like. We can go ahead and delete that. But we don't want to accidentally apply this to the prefab and change the prefab completely. What you can do if you don't want to do that is right-click and just hit Unpack Prefab. And now it'll no longer be prefabbed and it'll no longer be able to change anything. So let's do those with these as well. Let's unpack those so they're not going to change anything. And I'd say that looks pretty good. So now, like we've done with the game objects here, which I guess we could give them a better name, maybe call them platforms, but really they're just prototype game objects. It's not that important. And the player here, we're going to right click and we're going to create an enemy. So create empty. We will call this the enemy. I'm going to reset the transform so it's at 0, 0, even though we're going to end up probably changing it. And similar to the player, I'm going to make an enemy layer, which will be useful. So let's just create enemy. So under enemy, we'll set the layer to enemy. And let's create a sprite for it. So sprite renderer. Now, what sprite do we want? Well, you could import an extra sprites if you want. But for right now, we have the player sprite there, and we also had the enemy sprite. So if we go, I'm not seeing it right now in the scene. I might have missed it. These are just all these sprites are all sort of added in with the standard assets. Are just these like generic ones. You can use it if you want, this robot guy. But I'd like to, I'm going to use the shadowy figure here. Here he is. You could also, if you don't want to search through all those, you could just go to the sprites folder and just drag this over here. Alright, so we've got the enemy right here. And what do we want to do with it? Well, if we want to make it sort of basic, it should be able to at least move left and right. It doesn't. I don't think it really needs to jump, and then be able to do things when it interacts with the player. So let's put it here, and then let's add components similar to the player. So we are going to add, what was it, the body collider and the feet. So let's do that. So box collider 2D. We'll edit that down. Whoops. Edit that down a bit so it's just covering. It doesn't need to be exact. It just has to be closer in than the body collider. This one is a bit of a weirder shape. It's not as symmetrical. And then we'll do a capsule collider 2D. Not how you pronounce it, but it's how I like to say it because it sounds cool. I keep clicking off. That's no fun. We'll adjust that. So for the enemy, I like to have a bit of a wider hitbox than the player, because when you want to actually feel like you're killing it, and not feel like you have to get really, really, really in close. So is this exact? No, but really it's pretty much like the best we can kind of do with it still feeling relatively natural. So I'd say that looks pretty good for the enemy. So then what we're going to need to do is create a script for the enemy, just like we did with the player. So create C# script into our scripts folder, and we'll call this enemy. Pretty straightforward. We can go back into our enemy and just drag, there it goes loading in, drag this in. And before we do anything else, I think it's a good idea to prefab this enemy script. So we'll just drag it into our prefabs. Oh, and I almost forgot. We also need to make, you might have been yelling at your screen for a second, where's the rigid body? So it has a physics behind it. And yes, we do need to add a rigid body for now. Alright, So now that we added that, we can apply it to the prefab, and I'm just going to save Unity real quick. And now we can start getting into the script. So let's double click that. So what do we want the enemy to do? Well, it should be able to move left and right. That's a pretty good basic place to start. So we'll create a function just like these two, and like we've been doing before. We'll just say void, we'll call it move. Make sure not to do an animator move there. And so if you do accidentally, like I did, if you try to create it and it creates that, you can just hit Command Z or Control Z and it'll undo that. So under move, what should we say? Well, as a good start, let's have it move to the left. So we will say transform dot position equals, and if you remember, we're going to create a new vector2. That's not what we're doing. So let's make it move to the left. So if you remember on player, to edit velocity, you have to create the rigid body 2D, and then you're going to want to basically declare what it is. It's going to be my rigid body, and then you can edit the rigid body dot velocity. So let's do that over an enemy. So we're going to say rigid body 2D. We can call it the same as the player. If we can just call this my rigid body, just like we did on the player. Under start, we'll say my rigid body equals get component. In the little arrows, we'll put rigid body 2D and end it with parentheses and a semicolon to say that's the end of the line. Now under move, we'll say that we want my rigid body dot velocity equals, and we need to create a new vector2. And in this new vector2, for the x, let's say we want it to go left, so that'll be a negative x. So we'll say, just as a start, negative 1f. And then the y, we will remain the same. So my rigid body dot velocity dot y. Okay, so now back in Unity, we'll hit play. And it isn't seeming to move. Well, let's try to figure out why. So in here, it's on dynamic. Okay, it shouldn't really make a difference if we switch it to kinematic or anything like that. Oh, I know why it's not moving. This is a little mistake I made. We created the move function. We didn't put in an update. It's never calling move. Let's do that. Move. Then parentheses, semicolon. Save that and go back into Unity. So now if we hit play, it should move. And it topples over and then it's moving. And if you remember from the last lesson, our player did that as well. And we can fix that really easily by, under constraints on rigid body, just freezing the rotation with that little check. Now if we hit play, alright, it is actually moving correctly. And maybe that's the speed you want, maybe it's not. So for now, we'll apply this. And just like before in the player, instead of just saying negative 1f, we'll create a variable. So we'll just call this move speed. And then we have to declare it, so we'll serialize field so we can edit it. And it'll be any number, it doesn't have to be an integer, so it'll be, if you remember, a type float. And then just say move speed. Alright. And then back into Unity, under the enemy, we now have the move speed option. So let's say 1.5. Alright, and now it's moving to the right because instead of a negative, it's a positive. So let's set it at if we say negative 1.5, it's going to move to the left. And I actually think, ignoring the wonky player collision that we'll fix in a bit, I think that's a decent enough speed, maybe a little faster. You can tune this to however you want it to be. I think a -2 would work well for what I'm trying to create. Yeah, that seems, it's fast, but doesn't seem like overly fast for a basic enemy. So now, what should it do? Because right now, if we hit play, then it'll start to move. We can just jump over that. But then when it hits the wall, it's like, I'm done. And then it's not gonna do anything. So we can hopefully try to fix that. So we'll create another function instead of move, and we will call this one change direction. So void change direction. Alright, so what should we say under change direction? Well, we want to make it so if the body collider is touching the wall or touching something of ground layer, then it'll start walking in the other direction. So, and the reason the body collider should do it is that since this is farther out than the feet, the body collider will be the one touching the wall and not the feet. So we have to declare the body collider. So let's go ahead and do that. So just like we did before, this will be a capsule collider 2D, and we'll just call this my body. Under start, we'll say that my body. Actually, let's make it my body collider because that sounds similar to my rigid body, just without the rigid. So that's not how you spell collider. So my body collider equals get component, and the squigglies, what are we going to make it? Well, we're going to say the capsule collider 2D, then the parentheses, semicolon. So under change direction, let's say, so we have to say that if the body collider is touching the wall, and that'll be of a layer of type ground, then we want to do the effect. So if, parentheses, my body collider dot is touching layers, layer mask dot get mask, then in this set of parentheses, the name of the layer, and back in Unity, just to double check, these are of type ground under layer. If for some reason you have it set as like default, you can just switch it over to ground and save that. And so we're going to say in quotes ground, make sure it's spelled correctly, right number of parentheses, so then do the squiggly brackets and hit enter for our effect. So if the body collider is touching the ground type, which will basically be the walls, since the feet would be touching the actual ground below it, then we want to change the direction. And a good way of doing that is currently when we're moving, we have our move speed. If we just multiply the move speed by -1, it'll move in the other direction. So we could say that move speed equals move speed times -1. However, there's an even simpler way of saying that. If we want something to equal itself plus minus times something, we could just say move speed, move speed, not a seed, times equals -1. And times equals is basically saying that move speed is itself times -1. You could say plus equals for itself plus, you could say minus equals, but we're going to go with times equals -1. And then an update, we'll make sure to actually put it in this time, change direction, semicolon. Now let's go back into Unity and then see what's going to happen. Alright, jump over that. It's going to hit the wall. Alright, and it is making a little fuss there. The reason that's happening is, oh, it looks like it fixed itself. Let's see what happens now when it collides into this one. Alright, it keeps pushing off and on, and then it's taken a little while, so that's a bit of a glitch that we'll have to fix. And the way we can fix that is by basically creating a new collider, a trigger, so that way it's not right when it touches, it's when that collider touches, it'll change. So a good thing we can do is basically just create it on one side, and then we'll have the sprite flip. So then when it hits the wall, the collider on one side will flip to the other side so it won't hit. Sorry if that may sound a bit confusing at the moment, but let's just try this out. So right now we're basically saying that we want the move speed to multiply by -1 whenever it touches the ground layer. So we could also just add an O and flip the sprite there, but we should a better way of saying that is basically saying if the move speed is negative, then you face left. If it's positive, then you face right. Because otherwise, if we just say it here, then right when we start the game, if our move speed starts positive or starts negative, it might be facing the other way. So let's say, create a new function and just say void flip sprite, just like we had in the player. And then in here we'll say if, so we want to say if it's the move speed's negative, then we want it to be facing the left. So if move speed is less than 0, then we want to say that it's the transform.local scale. So we're going to say that transform.local scale down here equals a new vector2. And then in this, we're basically just going to say, since it's going to be less than 0, the x is going to be -1f. And then for the y, we can just keep as 1f. And then if move speed is greater than 0, then in here, made a bit too many spaces there. We don't need that many. We can just copy this and paste it in, and then just change the -1f to a +1f. So let's fill that in, the flip sprite. And now we'll see what happens when we start it. Alright, so immediately the sprite flipped. Let's, sorry enemy, let's get out of the way. And then it's still having that issue, so we do need to create an extra collider just to check that. Because otherwise it's still going to have that little bumpy. So, under the enemy, we can apply all for any changes that were made. If you have that, we're going to create a new collider. So if we create a new collider, we can't create new box or capsule colliders. You can only actually have one. So we can create a new collider. The best one the one I just go with off the bat is a circle collider. And we will just edit that. So the circle colliders, well, let's see, it's always going to be facing this way. So this way is always going to be the way it's facing, even if it flips. So if we put this to the right side, so sort of right there, and then if we were to hit play, since it's going to turn left, all of a sudden that collider turns to the left. So if we go back into Visual Studio, then we will say, under change direction, instead of my body collider, it'll be the circle collider. And there should be a better name for it than circle collider, because what that is, that's really just checking the wall. So let's call it the wall collider. So that'll be a circle collider 2D, my wall collider. Then under start, my wall collider equals get component circle collider 2D. And now there is a way you could do this without an extra collider using what's called a raycast, which is basically a field of vision. We're not going to get into those in this course. Those are a lot more complex than what we're going to be getting into. But after you're finished, by all means, if you want to keep doing some research and learn how to do that, then I highly encourage you to just learn more Unity after this course. So then, when we get into our change direction, instead of my body collider, we'll change that to my wall collider. Now, let's save that, go back to Unity, and hit play. And now it should finally work correctly. So we have the wall collider, is that little circle right there, touches it, yay! And now it is flipping to the other side. So now it'll touch that side and then flip back. Excellent. So let's apply that extra circle collider and we can save this. So now that we have this all working, the next step is to be able to kill the enemy. So that's going to be something we want to do under player. And now you might think, okay, we'll just say if the player is touching the enemy layer, then you will destroy it, or destroy the enemy. And you can do it that way. Problem is, there's that little circle collider that we don't want to exist. So a better way of doing it, and this is something that I'm surprised we actually haven't talked about yet, but I guess it just hasn't come up because it is an important part of Unity, is creating a on trigger enter, or on collider enter. So we're going to say on collider, or on collision enter, and then there's also on trigger, but since we want it to be the collision and not on a trigger, we'll say on collision enter 2D. And now there's also exit 2D and state 2D, but we want to say when the player comes into contact with the enemy. So that'll be on collision enter 2D. And now it'll give all this stuff. So collision 2D collision. And that's basically saying, well, what the collision is. So in this case, it'll be the enemy. And the best way of doing this isn't actually by saying, is the layer an enemy? It's a lot simpler to use what's called a tag. So if we go back into Unity, we'll see that under our enemy, it has layer and then tag, which is untagged. So we can add a tag, and then we can just add this tag and call it enemy. And you can do it by layer, but it's just when coding, it's a lot simple when you're doing collisions to just use a tag. So under tag, we will say that this is an enemy, and we can apply that. So what do we want to happen? When we collide, when the player collides, and when it's an enemy, we want an effect to happen, whether that be the player dies, or the enemy dies, or something else. So on the collision enter, we will say that if, and we have to check to see if the tag is an enemy. So if the collision dot, and the way you say that is dot game object, so that's whatever object is connected to the collision, which in this case would be the enemy, dot compare tag, and then in parentheses just type enemy. Then let's just say, just for testing purposes, we'll say debug.log colliding, and save that. Now back in Unity, if we hit play, let's go to our console, we touch it, and there we go. Now it says it's colliding when we touch it. So let's try that again. Boom, colliding, and it's only when you enter the collision. So I stand on it, it's not going to say it a bunch of times. And you may notice that we have these little, seems to be an error, saying that we can't use the velocity on a static body. And that's, if you remember from the very first lesson, that's not going to cause any issues, but we have this example script basically trying to move these platforms that can't move because they're static. And it's like, why are you doing this? So it's not going to cause any issues. It's just going to give that little like, why are you doing this message? But just for the sake of it, let's just remove these, just to make Unity happy. So you don't have to if you don't want to. They're not doing anything. But I'm going to go ahead just because, whoops, I hit move up there instead of remove, just because those little yellow things can get a bit annoying when they don't really mean anything. And the other thing that I just realized we need to fix is that currently we have this little collider here. We need to make that a trigger, because right now the player could just stand on that, or anything could just touch it. So if we set that to a trigger, and then we see what happens, and it should still be able to bump into that because it's saying, oh, it's still touching that. But if the player tries to touch it, it'll just go right through because it doesn't have any real interaction anymore. Cool. So let's apply that to the enemy and save that. All right. So next step in our journey to make a working enemy. So we have currently, it'll say that it's colliding, so that's good. We know that that's working. We can delete that. So basically we want to say that if the player's feet are touching it, then we kill the enemy, because if we want to do it, say like a Mario style where you jump on the enemy to kill it, then the feet need to touch it. But if the body's touching it, then there's going to be a little bit of an issue, because then the player should be killed. So so basically saying when it collides, if my feet dot is touching layers, layer mask dot get mask, and we'll call this enemy. Then we'll just see. At first we'll just make sure this works. So debug.log feet touching. Save that. Go back to Unity. Try jumping on top. And yep, the feet were touching. Excellent. And we'll just try this once again. And I completely missed that time. So let's wait for it to come back around. And boom. Feet are touching it. Excellent. So now, instead of feet touching, let's say we want to destroy the enemy. So the way you can do that is hit destroy, and then in parentheses, what do we want to destroy? We want to destroy the game object that we're colliding with. So we will destroy collision.gameObject. Save that. And back into Unity. Jump on it, and it disappears. Now, one thing you might want to do is add a little bit of like an oomph, like a little jump when you hit it, because right now it's touching it. You stop for a second when you're on top, but then it just disappears. So let's add that. Let's basically add when the feet are touching the enemy when they collide. Before it's destroyed, let's just add a little bit of upward velocity. So we'll create, just like we have the jump force, what do we want to call this? Let's say the serialized field float, the enemy hop force. Sounds like a very, very odd police movie. The enemy hop force. So then we're going to basically say that my rigid body, just like before, dot velocity was new vector 2, and we only want to change the y. So the x, we can just say my rigid body dot velocity dot x, and then for the y, we want to make the y velocity the enemy hop force, our little police squadron there. So I'd say, at least in my opinion, I want this to be a bit weaker than the jump, because you're just kind of hopping up the enemy, not really jumping yourself. So whereas, say, if we go into our player script, whereas the jump force has a 9, let's start this off as around a 4. Hit play. There we go. I think we can make it a bit higher. I think if we say it maybe like a 5. And keep in mind, these are floats, not integers, so you can absolutely change it to whatever decimal you want. Yeah, I like that. I like that little edge of force there. So I'm going to apply this to the player and save that. And then the final thing we need to do is make it so if the enemy touches the player's body and not feet, the player is dead. Now, we could just basically say a similar thing where, okay, if the body's touching, then we destroy the player. But then hold on, we're going to be stuck in the middle of a game. And so instead of doing that, if we restarted the scene, then it's basically like, all right, you died, let's restart. And I'd say that's a better way of losing, is losing and then being able to restart, as opposed to losing, the player disappears, and then you can't do anything, and you're just stuck there. So we're going to have to edit the scenes. And similar to how we had to say edit the inputs, you're going to say using Unity Engine dot scene management. And then we can basically say that, okay, we want to just reload the current scene if the player gets hit. So instead of if the feet are touching layers, we'll say that if we haven't actually added the body collider. We need to do that. So we're going to say a capsule collider 2D, my body collider just like we did when we made the enemy. In start, we'll say my body collider equals get component, and then we'll say the capsule collider 2D. I almost said the body collider 2D. That's not a thing. And then back here, if my body collider dot is touching layers, layer mask dot get mask enemy. Then, alright, got right number of parentheses. So if my body collider is touching the enemy and not the feet collider, we want it so the scene restarts. And how we'll do that is to we will say scene manager dot load scene, and we want to load whatever the active scene is. So in here we're gonna have to type scene manager again because we have to get the active scene. Dot the command is get active scene. Add parentheses because that's a command. Dot build index. It's another long command that you just have to. The more you do it, the more it'll just stick into your memory. Sometimes I forget it quite often, actually. But now, when we hit play, if we touch it, all of a sudden the scene's going to restart. Excellent. So now our player's dying in a way that we can just restart the game. And then there we go, we killed the enemy. So that's going to conclude this lesson. Make sure to save everything up. The next lesson, we'll actually get into creating a better world than whatever this is. So have a good day, and I hope to see you next time.